Hey guys, welcome to day 6 of solving LeetCode daily challenges. So today's problem is meeting rooms 3. Let's see what is this problem states. We are given with an integer n, that is there are n number of rooms numbered from 0 to n minus 1, and a 2D integer array meetings is given which has start and end in it. Let's say a meeting will be held during the half closed intervals, that is like start and end. What is mean by half closed intervals? That start is included in the interval and end is not included. That means if we have like 8 to 10, let's say start is 8 and end is 10, we have to include this 8 as a time, and we may not include this 10. So this is called half closed time interval. And what is the given conditions to allocate the rooms? Each meeting will take place in an unused room with lowest number. Let's say there are some 3 rooms and 2 rooms are unused. Okay, so 1, 2, and 3. So here, let's say this is not free, and we have these 2 rooms. Let's say this is room 1 and this is room 2. So we need to use the smallest or lowest room first when there are more number of unused rooms. Next condition is if there are no available rooms, the meeting will be delayed until room becomes free. And the delayed meeting should have the same duration as the original meeting. When a room becomes unused, the meetings that have an earlier original start time should be given in the room. Let's say there are like 2, 3, and 4. The next meeting should be given to the lowest start time, or can we say like 3, 2, and 5 are there, and we need to give in such a way that 2 should first engage the room. Let's understand this problem carefully. So let's first understand the given problem. Can we say like we have 3 rooms, or like 3 rooms, right? So it will be like 0, 1, 2, and 3 rooms are there, and we have already taken the meetings and scheduled it few meetings in the rooms, and all the meetings are engaged. Let's say we have 5, 3, 7, and 6 as the end times of the meeting. These are the end times, and we need to schedule 2 to say 6 and 8 to 10, both meetings. First we need to schedule this meeting. So let's check which room can we allot the meeting. So as we can see, that lowest is 3. So here we can schedule the next meeting, but the meeting should start from 3 and end at the duration, that is 6 minus 2, it will be 4 plus 3, that is, can we say it as 3 to 7 is the new scheduled time or new meeting time, as the meeting's duration should not change. So we have allow the meeting as 3 to 7, and this 3 will change to 7. Now we need to allocate this particular meeting and its duration is 2. So we'll check which is the next possible room we can allocate. We see that 5 is the smallest one, and here we allocate the meeting. Also we can see that 7 is smaller than 8, and 7 is also smaller than 8, 6 is also smaller than 8. We see that 5, 7, 7, and 6 are the end times which are lesser than 8. So in this case we take the smallest one. As we see that the end times are different, or end times and start time is has much more difference. So we can say that all the rooms are free. So we use the lowest one. So we allocate here as 8 to 10. And now let's think of a solution. What are we doing? We are just prioritizing the rooms as lowest number of end times are taken, and from here the lowest meetings are taken first and arranged into the rooms. Can we think of a approach with priority queue, that is we are prioritizing the schedules? So okay, let's use this and see what will be the approach. Let's say meetings equals to 0 to 10 and 3 comma 5, or okay, 1 comma 5, 2 comma 7 and 3 comma 4. We are already taking a sorted array in this case. Let's say we have only two number of rooms. Let's take n as 2, and first of all we'll take two rooms as 0th room and first room. First schedule the first meeting in the 0th room to 0 to 10, and next meeting to first room, that is 1 to 5. Now we'll come to the next meeting. Let's say that n times will be 10 comma 5. We see that 5 is the lowest one, in lowest n time in this meeting or in the rooms. So we'll just append the next meeting into the second room. But here we see that 5 is greater than 2. So the delay time will be 3 units of time. So let's say that here the meeting will be scheduled, but it will start at 5 and the duration of the meeting will remain same. What is the duration? That is 7 minus 2 equals to 5 is the duration of the particular meeting. So the duration of the meeting should not change. So the next meeting will be 5 to 10. We can see that 10 and 10 both are equal in this case. And next meeting is 3 comma 3 to 4, which is 10 is less than 3 in both cases, but we see that both have same end time. Which should we choose? In this case we need to choose the lowest index room. So we'll just schedule it as from 10 to, the duration should be equal. So let's say the duration of this meeting is 1 unit of time, so it will be 10 to 11. We see that there are two meetings possible here and two meetings possible here. 2 equals to 2, so we need to return the index of lowest room. So we return this particular 0th room as answer. Let's think of another solution using priority queue. Let's take a meetings as meeting equals to 1 comma 10 or 1 comma 20, 3 comma 5, 2 comma 6 and 9 comma 10. Let's take the simple example with number of rooms equals to 3. First we need to sort it, because we need to take the start time in the increasing order. We should take the lowest start time of the meeting first. So we'll just sort it out as, we'll get 1 comma 10, 2 comma 6, 3 comma 5, 9 comma 10. So this will be the sorted meetings array. And let's first initializing a priority queue as use priority queue. Let's take it and initialize it with time comma room number. Initially the time will be 0 and rooms will be 1 or 0, 1, 2 in this case. So let's say we have 0 comma 0, 0 comma 1, 0 comma 2 as the starting. Let's first schedule the particular meeting or first meeting. We see that 0 is less than 1. So we can schedule this meeting in any of these rooms. So let's just update it by 1, 1 and 1. And now we'll check if this particular meetings can be arranged or the duration should be updated. So let's just update the end time. Let's take 1 plus the duration of this meeting as 20 minus 1, that will be 19. So 1 plus 19 equals to 20. So just pop it out and append 20 comma 0, and let's take a array count to keep the update of number of meetings. So let's say 0 0 0 initially will be our count. So as we schedule the meeting in the 0th room, so update or increment the value of the first or 0th room by 1. Let's schedule the second one. We see that the lost element, or pop it out and see if time is less than or equals to the start time of current meeting. So we can say that 1 is less than 2 in both cases. So we can schedule the meeting here or in the room 1. So just update it as let's say we are using 2 in both meetings, so 2 can be in first room or 2 can be in second room. Let's see, first we can change this end, or we can change the end time of the first room. So the end time will be 2 plus the duration of the room, that is 4. So 2 plus 4, it will be equals to 6. So just update or pop it out and append this value as 6 comma 1 and increment the value of number of meetings in count array. Let's take this third meeting, that is 3 comma 5. We see that only the particular 2 or the last meeting held in the second room is less than the start time of current meeting. So we can say that 2 is less than 3. So just pop it out and change it as 3 comma 2. Now we need to change the end time or duration of the meeting. So increment it by 3 plus the duration. The duration is equals to 2, that is 5 minus 3 equals to 2. So the duration will be 5 in this case. Let's just update it by 5. So now the array and the count will increase to 1. Next we have 9 comma 10. We see that 6 is less than 9 and 5 is also less than 9. So just change these values as 9 comma 1 and 9 comma 2. So let's append the updated values as 9 comma 2, and here will be 9 comma 1. As we are using a priority queue, the lowest will be in the bottom and the highest or largest will be at the top. So we have appended it. We see that we need to append the lost element or lost tuple in the used array. So the duration of this particular meeting is 1. So 9 plus 1, it will be 10. That is, we need to change it to 10. So it will go here. And we need to also increment the room one's meeting by 1. So total number of meetings will be 2. So we see that room 1 has largest number of meetings, that is 2 meetings are held in the first room. So we need to return the index of the first room. We can say we are returning the first room as the result. Let me see that we are sorting the particular meetings array and we are incrementing the values one by one into the used array. Every time we are just incrementing or pushbacking every room's start time. So we need to think of another approach, like can we optimize this particular approach using two heaps or two priority queues? Let's see if we can do that. Let's take the same example as m equals to first sort it. Okay, so there are three number of rooms. Let's take count array. and initialize it with zeros as we are having no meetings in initially. Let's take two priority queues, that is one will be my free array or free priority queue and other will be used priority queue. And initially add the all number of rooms, like we have 0, 1, 2 as number of rooms in used, or there are no rooms used, so we append it into the free priority queue. Now we need to check for two conditions. If the used is empty or and free is empty, we can see that use is empty, so we'll just pop the free one because free is not empty and add it into the used array as the first meeting's end time. Here we don't use any start time because we are using the end time for the next one also, so we just ignore the start times. So add it like 20 comma 0 into the used array. Now for the next room we see that used is not empty and free is also not empty. We need, as used is not empty, compare that is this start time less than 20, it is greater than 20, right? So we can't add any meeting into the zeroth room, so we use the first room and add it like the end time of the second meeting as, say, we are adding it in 6 comma 1, and here we have engaged the first or zeroth room, so increment it by 1. Now let's take next room. We see that 6 is greater than 3, so we can't use this room or we can't use first room to arrange any next meeting in the particular room, so we just pop it out from the free room and add this 5 comma 2 and increment this by 1. The priority queue will change, like the topmost will be greater than the lowest, so let's say 20 comma 0, 6 comma 1 and 5 comma 2 are there. The next meeting we see that the particular used array is full and free array is empty, so check if this particular meeting is less than the start time of the next meeting. So we see that it's true, so just empty the particular room and add it, and we can see that this meeting is also having lesser time than the particular end start time, so just pop it out and append it into the array or priority queue. So now we see that for this meeting the first or lowest will be 1 and we allocate it as 9 comma or okay n times, so 10 comma 1 and increment the count by 1, so it will be 2. We see that we have engaged or scheduled every meeting in the meetings array, so just return the largest scheduled meetings index. So we see that we have scheduled 2 meetings in the first room, so just return 1 as answer. So let's move to the code part now. Okay, so let's code using single priority queue first. So used equals to say 0 comma I per I in range of n, that is we are allocating 0 rooms or 0 start time and room number. Next you are using a count array to count the number of meetings arranged in a particular room and sort the meetings array according to the start time. Next iterate through the meetings array, take every possible start and end in the meeting. Let's check if the used array is empty or not, and also the least index start time or time is less than the current start time. If it's true, let's say used of 0 comma 0 is less than the current start time. If it's true, then what we'll do, we'll just update the current start time with the previous ones, like previous room, we'll just remove it from the used priority queue and update it like heap push of the used comma, we are updating with current start time and previous room. We'll do this because we are allocating the start time for every possible room. Let's say we have 000 and we can allocate this particular first meeting in every room. So if it's not true, or let's say we have allocated every possible meeting in the room. So after this, we'll just take previous n and previous room equals to heappop of used. That means we are taking the previous and let's say we have appended start or current start here. It will be the current start itself. Or when we are updating to the next meeting, we'll use the previous and update this with the current duration. So let's say we are updating the duration. So heap push of used comma previous n plus now n minus start, that is duration of the particular meeting or current meeting, comma we are uh, pushing it or allocating the particular meeting in the previous room itself, and next increment the count of the previous room by 1 as we have allocated one meeting here, and after the whole iteration, that means every meeting is allocated, just return the index of maximum number of meetings held. So let's say we are returning count dot index of max of count. Let's check if this code runs fine. The code runs fine for the given test cases. So let's see if it submits and runs for every possible test case. Okay, so the code runs fine for every possible test case with single priority queue. Let's see the time complexity here. We are sorting, so it becomes or let's take m as number of meetings. So the time complexity of sorting will be order of m log m. And while popping or while pushing the meetings into the used array, we are using n rooms, right? So it can be n log n. So it is time complexity of n log n, and the total complexity will be m log n plus n log n. Let's move to the code of using two priority queues. Let's say we have free priority queue as free of I for I in range of number of rooms, and we have used room. It will be empty initially. Let's first heapify this and we'll just sort the meetings array. So meetings dot sort of. Now iterate through the meetings array as press comma e in meetings, and now we'll check for two conditions, like while used is empty, sorry, it's not empty, and the used of 0 comma 0 should be less than or equals to the start or current start. If it's true, what we'll do, we'll just update the room, right? So heap pop of used array, and we'll update it into the free array. So let's say heappush of free comma room number. Why we are doing this is we see that our the room is allocated, but the particular time or the meeting is already completed, or let's say it's completed at 10 and the next meeting is started or will start at 11. So we'll just free out the room and push back into the free priority queue. And let's say if used is empty, what we can do, we'll check for free is free empty or not. Let's say length of free equals to 0. If it's true, then what we'll do, we'll just take the next n and room number equals to heappop of the particular used array, that will be the next n, and push it into the used array as next n plus the current n. That means we are delaying, in this case we'll check if the meeting is delayed or not, and if the meeting is delayed, then we'll just do the next n plus current n minus start, that is the duration of the meeting. It will be the end, total end of the meeting, and the room number as r. Let's say what if there are some free rooms in the free priority queue, else just take room number equals to heap dot pop of free, and we'll just push this particular room into the used array as used comma current n comma rooms, and now we'll just increment the count. Okay, so initialize the count equals to 0 initially for n rooms. When we are allocating a particular room, we'll just increment the particular room's count to 1 or by 1 and return the maximum of index. So index of max of count, we are returning the maximum number of meetings in the counter is index. So I'll just run it. So the code runs fine. Let's submit and see if it's possible for every test case. Yeah, the code runs fine for every test case. Let's see the time complexities. It will be same, like we are using a sorting technique for n log n or m log n, and we are pushing back the n number of meetings. So it will be m log n, or we can say log n. So total time complexity will be n log n plus log n. So that is it for today, guys. Hope you like the video. Please do like, share, and subscribe if you like the video. And meet you tomorrow in the next diary challenge.